Three-phase induction motors are characterized by their self-starting ability, simple in construction, and relatively constant speed that varies with the load. They are cost-effective, require low maintenance, and have a high starting torque. Therefore, induction motors are used in a wide range of applications, which includes driving industrial machineries like pumps, fans, and compressors, powering household appliances such as washing machines and refrigerators, and propelling electric vehicles and trains. They are also used for air circulation and in automated systems for robotics and manufacturing. A starter is an electrical device that limits the high starting current drawn by an induction motor. It provides a controlled start and also offers protection against overloads and undervoltage. It works by reducing the inrush current, which can be 5 to 8 times the full load rated current. For example, if full load rated current of motor is 10 ampere, then inrush current can up to 50 to 80 amperes. Such large current is very harmful for induction motor. Therefore, starters are used to limit this current. Common types of motor starters includes direct online starter, star delta starter, and stator resistance starters. Hello friends, I am Professor Kiran Kumar. In this video, we will learn a direct online motor starter, their power and control circuit along with their applications. But before that, if you have visited first time to my channel, kindly subscribe and press the bell icon to get the notification of upcoming videos. In a DOL starter, an induction motor is connected directly across a three-phase supply, and the DOL starter applies the full line voltage to the motor terminals. It is generally used for the motors up to 5 HP. Common applications include small motors in pumps, fans, blowers, conveyor belts, and compressors, particularly in industries like agriculture and manufacturing. These starters are ideal for low rating motors where a high inrush current is either acceptable or manageable without causing significant voltage dips. The power circuit of a DOL starter consists of a power source connected in series with a protective devices like an MCB or fuse, a contactor, and an overload relay before reaching the three-phase motor. MCB or fuse provides the initial protection against short circuit. It is the first component in the power path from the main supply. Contactor is a switch which is controlled by an electromagnet. Its three main contacts close when the contactor coil is energized to allow power to flow to the motor. Overload relay is placed in series with the motor. It protects the motor from overcurrent. It can be a thermal overload relay, which trips when excessive current hits the motor winding to a dangerous level. Motor is the final component connected to the output of the overload relay. When the start push button is pressed in the control circuit, the contactor will get energized, which close its main contacts to complete the power path and apply full voltage directly to the motor. The overload relay is wired in series with the motor to protect it from overcurrent, and it will open the circuit to stop the motor if it trips. The control circuit for a DOL motor starter consists of a stop push button which is having a normally closed contact, a start push button having normally open contact, a contactor coil, and an overload relay contact. All components are connected in series. It also consists of an auxiliary contact which is connected across the start push button. Stop push button is a normally closed push button. When pressed, breaks the circuit and stops the motor. Start push button is a normally open push button. When pressed, initiates the starting sequence. Contactor coil is an electromagnet that closes the main power contacts to supply power to the motor and also close its own auxiliary contact. Overload relay is a safety device that trips the control circuit in case of an overcurrent condition to protect the motor. Auxiliary contact is a contact on the contactor which is connected in parallel with the start button. This contact holds the circuit after the start button is released, keeping the contactor energized. An auxiliary contact is interlocked with the contactor coil such that when contactor coil energized, auxiliary contact get closed. And when contactor coil de-energized, auxiliary contact will open. When the start push button is pressed, it completes the circuit and energizes the contactor coil. The contactor then closes its main power contact to start the motor and also close an auxiliary contact which bypass the start push button, allowing the motor to continue running when the start button is released. The overload relay contact is connected in series with the start button and act as a normally closed contact that will open and de-energize the contactor coil if an overload condition occurs. When the stop push button is pressed, it interrupts the circuit and de-energizes the contactor coil. The contactor then opens its main power contact to stop the motor and also opens an auxiliary contact. DOL starters are simple to install, operate and maintain and are more affordable than other starting methods. They provide high starting torque, which is beneficial for applications that need to start under a heavy load like overhead cranes or propelling the train. Apart from all the benefits of DOL starter, it suffers a drawback of high starting current. DOL starters draw a very high inrush current, typically 6 to 8 times the full load rated current when the motor starts. This high current draw can cause a significant voltage dip in the electrical supply network, which can affect other connected equipment. Therefore, DOL starters are only used for smaller motors, where a high inrush current is either acceptable or manageable without causing significant voltage dips. So friends, this is about DOL starter. If you found this video useful, hit the like button and also share with your friends. Subscribe to the channel and press the bell icon to get update of all upcoming videos. Till time, keep learning, keep growing. Thank you.